Hi, folks, and welcome back to another episode in Building Your Boombot, the BCIT Technology Teacher Education 5060 project that I'm happy to share with anybody else who's interested in doing it. We are starting to run out of things to do on this board. We've come a long way. We've gone from getting our drive up and running to using the ultrasonic rangefinder, the H2 HCSR04. Where did I put my rangefinder? Ah, yes, this little device right in here. We used it for range finding, but when I built the board, I left a few sockets on here that were going to be multi-purpose, and you can see I've got devices plugged into them right now. So I've got one right here, one right here, one right here, and one right here. So we've got 4 ports on there, and they're what we call I2C, I2C, however you want to say it, um, ports. And those are designed for inter-IC communication. That's what the I squared C comes from, inter-IC communication. There's 2 I's in there for integrated circuit. And basically, they're a serial port. And what they let you do is they let you talk to a wide range of different devices. And what's neat is they share a common bus, in other words, a common communications line, so that we can have multiple devices hooked up to one I squared C port. So our Arduino's I squared C can go out. And in this case, I've got it talking to a rangefinder right in here, a little laser rangefinder that's pretty cool. And I've got it talking to a display screen. This is an OLED display screen, little 1-inch display screen. And over here, I've actually got it talking to a gyro. So if you want to measure how the robot is turning back and forth like that, this gyroscope can provide that amount of feedback. Now, I'm not going to talk about hooking the gyro up today. I'm just going to take a look at the rangefinder and the display. And there's so many different I squared C devices out there. You could put fancier displays on there and do all sorts of things. For instance, I've got another display right in here, and you can see this one's a little bit smaller. And although now that I look at the board, I didn't put everything in exactly optimal positions for making it all work. You can take cables like this, plug into the I squared C port, and put your display or your sensor or whatever it is that you want wherever you need it to go. So lots of opportunity. We've got 4 I squared C ports, and the cool thing is you can daisy chain them together or split them up so that if you want to add a whole bunch of I squared C devices, you can keep doing it until the memory of your Arduino fills up and your ability to handle it fills up. So anyways, let's take a look at the 2 devices that we're going to be talking about today. This one right here is this little display screen right down here. It's an OLED display screen that I picked up from Universal Solder. I'll show you that site in just a minute. And it uses a chipset called the the SH1106 on there. It came to me in this little box right here. See if we can get that to say, there we go, SH1106. Now there's another common chipset that's used for this, the SSD1306, and the driver that I'm going to talk about is able to use both those chipsets. So just hang in there if you've got a slightly different display. Something to note is that although most of your circuits use the configuration. Oh, let me pull out the rangefinder right here. This will show it. Um, Most of the little I squared C's that we're going to find at the hobby shops and all that, there we go, are going to have the configuration of VN, ground, serial clock line, and serial data line on there. So you can see I've got VN, GND, SCL, and SDA. Although most of them use that configuration, and that's what I've put on here, not all of them do. And this smaller display here, I forget what the chipset name is on that off the top of my head. You can see that this one is slightly different. So you do have to check this is ground VCC clock and data. Now you'll notice this one only has 4 pins, but when we were looking at the rangefinder, this one has a couple extra pins on here. And this is something that I didn't fully think through before designing the Boombot board. Where's my focus? There we go. You can see that this has a GPIO1, which is a suspected general purpose input-output for that chip. But the one I really didn't even think about was the X shut. Now that's a shutdown pin that enables you to turn this off. And that matters because each of your sensors has an address on board. So that's how we're able to put multiple chips together onto the same, or multiple devices onto the same communications bus, is that each one of these has its own name, essentially, an address. And what you need to do if you've got multiple devices that are the same, you need to shut down the devices that you don't want to talk to, and then you can go in and you can reprogram the address so that my original idea, and it could still work, it's just going to take a little bit of work to do, is that you'd have one rangefinder right here looking off in this direction, one rangefinder right here looking forward, and one rangefinder looking in the other direction, so that your robot, instead of just having one eyeball looking forward, would actually have three eyeballs looking off in different directions, and you'd be able to range find and have more sophisticated object seeking and avoidance routines on there. Turned out to be a little more difficult. The Arduino didn't have quite enough pins to be able to shut each of these down one at a time. And I had worked under the assumption that once you changed the address for your device, it would be able to remember that in some form of static RAM or flash memory. And not with this chipset, maybe with a different chipset, and I'll have to do some more research. But for right now, we're just going to use one rangefinder on here, and we can put a different device like a gyro. Maybe you could have an accelerometer tucked in over here, or a second screen. I mean, how many display screens does somebody need? Okay, so let's take a look at how to get this up and running one thing at a time. Oh, this is the other glitch that I made on here. Let me just power this down for a second. And it hadn't occurred to me when I put it all together, because I didn't model them both at the same time, that when you put your Canon's fire plug on there, that your screen doesn't really fit flush down there. And I'm just like, man, what am I going to do about that? And thankfully, there is a simple solution. You could use some cables and mount this somewhere where it's a little bit more visible on your robot. Or I was actually thinking, wouldn't it be neat if we cut a little hole in the front and mounted it right up there? Anyways, improvements that you can do on that. Or somewhere around here, I've got the solution I'm working with right now. You can take stacking headers, and you can trim them down and make them a bit neater later on. But if I stack them up like this, then I can pop that in there, and it's just as if it was plugged in, but now it's sitting a little bit higher so that the Canon connection can fit through underneath. You can see that I've also put a little bit of green tape right over top of the NeoPixel LEDs, and that's just to try and keep them from blurring the camera. We're actually using them at fairly low power, so they're not blinding my eyeballs right now, but the camera is a little bit more sensitive to light. So there we go, we start that up, and it says, hi, I'm a Boombot, because we've still got our DF player working well in there. And you can see I've still got a little bit of the Hello World code running in there. See if I can get it to focus on the display screen. Sometimes focusing on, there we go, I think that. That third line in there, it says, hello world, I'm a Boombot. And the third line right in there is reading the output from this time of flight distance sensor. You can see I put my finger in there, and we're down. It's telling me 71 millimeters right now. Now, it's not really accurate at the super close ranges, but it should be good out to a couple of meters. Of course, the downside is when you close your top, it gets a little more difficult to read that display screen when that's right inside there. So anyway, there's going to be something to modify for Boombot V3 perhaps, but at least all of our devices can come together and work. Let's take a look at some of the software that I'm going to use to make this happen. Okay, before we get to the software, thankfully I've set some of these screens up so I actually remember some kind of sequence that I want to talk about. I did want to talk about the hardware before I got into the software a little bit and how the board is configured. So I've got this screen right here from works so much better when I hit the transition button. Okay, when I've got this screen up in here, now you can see the schematic for the circuit board, and you can see that A4 and A5 right here are the pins that I was using for the ultrasonic rangefinder. And it at the time we started programming the ultrasonic rangefinder, I said it was really strange that I'd use A4 and A5 because although they're perfectly fine as digital pins, on a project like this, having them available as analog pins could be quite handy because they have that superpower on all of your analog pins of having the analog digital converter in there, which lets you read a lot of nice linear sensors that provide a 0 to 5 volt response. Well, anyway, it's a little expensive to use those fancy pins for, not dollar expensive, but resource expensive to use those fancy analog pins for a simple digital device like the rangefinder. But since I knew that we had a laser rangefinder as one of our I2C devices, which meant we could replace this, and since the Atmega 328P has a dedicated I2C port, using what turns out on the Arduino to be pins A4 and A5, pulling this out and replacing it with a laser rangefinder in here was going to be just the really simplest thing to do. So from day one of the design, this was set up on A4 and A5 so that we could pull it out, replace it with a laser time of flight sensor, and we'd have A4 and A5 available to have hardware I2C communications coming out right down here. So it's important as you get into microcontroller applications that you know a little bit about your chip and a little bit about the hardware that you're working with so that you can apply the hardware resources to make everything work as efficiently as possible. And here you can see the 4 headers that I've got on here, and I pointed those out earlier. You've got 1, 2, 3 along the front, and of course, your one tucked in by the Arduino for the display. Okay, so those are spread around on the board, and heading to them, we've got ground +5, and then A4 and A5. Now these are going to be your serial data and your serial clock. So when we use the UART port right down over here, RTX and RX, to talk to the ESP8266, that was UART was universal asynchronous receiver and transmitter. And that asynchronous is a key word because you'll notice that between the TX and the RX pins down here, there's no clock line. And that's what they mean by asynchronous. There's not a line, there's not a pin dedicated to basically being a metronome and saying when data is being sent. Okay, so we've got to time everything pretty precisely with our TX and our RX right down in here. We need to set the baud rate and have that agreed upon in advance so both the transmitter and the receiver know how fast the data should be flowing. With I2C, it's a little bit more flexible because you have a clock line, okay, your SCL pins. And the clock line is your serial clock, and it's going to be sitting there, and it's the timekeeper. Okay, so our host device, our master, the Arduino, is going to be sitting there generating that clock pulse. And so if its timing is a little bit off what everybody else expects, that's okay. All of the slave devices pick up that beat of the drum of the master, and they're like, okay, we're all in synchronicity here. I have a terrible sense of rhythm. So, and then we'll have our data line down here, and our data line, instead of just sitting there and having to get the timing right all by itself, will be in synchronous with the clock line, either sending ones or zeros down the line. 1, 0, 1, 0. Okay. Next thing I'll be doing the Macarena or something like that for you. But that's how this line is working. And this is why we have 2 pins for serial communication, whereas down here, we actually only have 1 pin that we're using. Now, you're like, well, wait a minute, we've got 2 pins down here. There's a transmit and a receive. The I2C communication makes up for using that clock line by being able to both transmit data from the Arduino and receive data to the Arduino along that data line. So there's a protocol where the Arduino will be able to send data out here, and then the host device, the host device, sorry, the slave device out here that receives the data will have an opportunity to respond. So that's built into the I2C protocol. Really cool what people have laid out in the chips to try and make things work efficiently. Now, there's a lot to know about the I2C protocol, and I'm not going to dive into the deep reaches of I2C, how it works and why it's wonderful. And once you get into I2C, you'll see that there's other communication forms. There's SPI, the serial peripheral interconnect, connect, so that you can start hooking up all sorts of different devices. And really, it's just a matter of pulses and timing them. And you can look at them on your trusty oscilloscope or logic analyzer, and you can actually see what's going on in here at super high speeds. So it's really cool how this all works. If you want to know more, you can just Google I2C, or if you're looking for some good background on how I2C actually works and some of the other things that you can do with it, give Arduino I2C a Google, and certainly you'll find stuff under all, but there's some videos out there. SparkFun's got one up, Circuit Digest. Anyway, lots of established tutorials where they do much nicer graphics than I'm going to do for you. Okay, and they'll delve into it in a lot more detail. Now, where I'm getting my devices from, Universal Solder imports these devices to a small town in the backwoods of Saskatchewan, actually the back prairies. There's not many woods in southern Saskatchewan. And so if you go to Universal Solder and Google up I2C, you can see that there's a whole bunch of other really cool devices down here. So there's a multiplexer. So that would solve some of our problems of having multiple I2C devices with the same address. You'd actually hook them into the multiplexer, and then your Arduino would send one signal to the multiplexer and say, okay, I want you to talk to the first device in the multiplexer and go out and get some data from that. Anyway, neat stuff that you can do. Here's that SH1106 screen, and really the SSD 1306 and the SH1106 are so similar in what they do as far as tiny little OLED drivers that they don't even separate them in your part number. If you order this, you might get an SSD 1306, you might get an SH1106. The libraries that I'm going to use mean that it doesn't really matter. In fact, there's a tiny difference in how they configure the memory inside. That means that if you use the wrong setting, it's not going to work. It's almost kind of going to sort of work just enough to be really frustrating and blow a few hours. Don't ask me if I have personal experience with that. Grumble, grumble, whine. But as we go down here, you can see that there's a whole bunch of different devices, smaller screens, and they're all pretty reasonably priced because a lot of these devices are being mass produced for consumer use in other devices. And that's really where us as educators and hobbyists get good deals on this stuff, is that these devices are all being produced for industrial uses where they order 10 million of them, and there's maybe 500,000 left at the end of the production run, so somebody else comes along and gets a bargain for them and slaps them on a little board so that they're easy to adapt to our projects. So there's lots of different suppliers of these devices, and of course one of my favorite local ones here in Vancouver is Lee's Electronics. And if you go into their website and search for I2C, you're going to find a lot. And the nice thing about having a local supplier is that I always get great service and support when I go into Lee's. So shop local, and you'll get some good advice when you shop there as well. Okay, so let's take a look at what we're going to do with this now. And in order to get this working, that's really tiny font. Let's reopen those windows here. I have no idea why that's coming up in such a tiny font. I'm going to change that up, and that's just weird. Let's set this to a bigger font. Okay, this should be, actually that's probably overkill. Okay, that I think gets everything onto the screen right there. So in order to make this work, we're going to need some libraries. Okay, and I mean, you could go and program it all from scratch, but life is easier with libraries. People have been out here and solved most of the big problems for you. So let's take a look at the display screen first. So come down to your Manage Libraries, and we've done this quite a bit before. And now there's a number of libraries that can be used with each of these, and I spent some time digging around to find ones that work for me. You're welcome to use other libraries if you find that they work for you, but I'll give you a couple of tips on how to get started right here. So the library that I'm going to use for the display screen is called U8x8. So if you search for U8x8, it's going to come up in here, and it actually comes up. Ooh, excuse me, half a second. All right, sneezing over. It's actually going to come up as the U8G2 library by somebody named Oliver. Okay, and you'll see that within that it finds the U8x8. And U8G2 is a more general graphics library. It covers a number of chips. So you can see in here that we've got the SH1106 covered right in here, but we also have the SSD 1306 covered in here. So this is going to work regardless of which of those I2C devices that you get. And it covers a whole bunch of other devices and other interfaces. A really cool library. And when you run it, it actually doesn't use up a lot of resources on your Arduino. So install the U8x8 library, or actually, I guess the U8G2 is the name that you should be searching for, by Oliver. And you can see I've got mine installed. And when you do that, you'll get, where are we here? Examples. I've got a few libraries on here. I tried a few different ones. Come down here to the U8G2 should now pop up in your examples, and take a look at the U8x8. Now, the difference between the full U8G2 that you'll get right in here, okay, this is cool, they've got games, they actually work, okay, and the difference between the U8x8 is that U8x8 is just for text, so it compiles into a smaller packet of memory that goes onto your Arduino. It's a little simpler for it to run. You can put more complex graphics on here. I'm just going to show you how to do the text today, but play around and have fun with it. There's neat stuff that you can do with these little displays. And I'm sure that when you look at the price of them, you'll be like, oh, I could make some other really cheap little cool projects and just use an Arduino Nano or something smaller and a couple of buttons, and I've got a little gaming console that I can play with 2 thumbs or something like that. So that's really cool too. Anyway, U8x8, come in here and you can try this and just go into the hello world code, okay? And hello world code comes up right in here. And you always want to try these things out. Just try the example code in the library to get going first. So take a look at what it has in it. It includes the Arduino.h should already be in your system. And then there's a whole bunch of pre-compiler commands in there. You can kind of ignore them, but pay attention to this comment right in here. There's a link to the website that has more information, but here's all of the different configurations that the library can use. And if you've got an 1306 chip, you can see that there's a number of different configurations for the SSD 1306. You can have a 128 by 64 screen, and then you can use the hardware SPI or the software SPI, okay? Or you can use hardware I2C or software I2C, okay? So there's all these different configurations. You kind of have to look through the comment and figure out, hey, which one do I want to use? And what we've got is the SH1106. We've got a 128 by 64 a display on this one right here. It's a no name. We're using not hardware SPI, but we're using hardware I2C, okay? And then there's yeah, all these other chips that you can go in there and use, but we're the SH1106. So you can uncomment the line right in here that says U8x8 SH1106. Now, if you happen to have got an SH1306, don't uncomment this line, okay? Because when you uncomment this, this is going to compile your library for the SH1106 chip, okay? And we're using hardware I2C, so we don't have to tell it which pins the clock and the data are on. You'll notice that if you use a software setting, that you do have to tell it what pins we're on. And we're not using the reset pins because we just didn't have enough pins on the Arduino to make it work. Okay, so if you're using a 1306, it's probably a 128 by 64 chip. And again, you're looking for the hardware I2C version. So if you ended up with a 1306, find that hardware I2C right in there, and you'd probably be uncommenting this line right in here. Okay, and as you see, there is a lot of different options available for us. Okay, and now what this is going to do is, it's going to test the board. This is all commented out right in here in your setup because we're not using these pins to enable or disable anything like that. And so basically it's going to run U8x8 begin, and it's going to turn off the power save mode by setting that to 0. And here we go. It picks a font out of the library. It draws Hello World. And if you've got an SSD 1606/7, you need to refresh the display. We can comment that out right in there. And you should be able to run that and put it up onto your Arduino. Hope I'm plugged into the right port here. And this is the point where you'll want to stop and test and make sure that everything's working with your display, with your clock lines, your data lines, that it's all hooked up properly, that you've chosen the right board. And don't try to jump on anything else that we're doing until you've got this working right here. And you just see that lovely little hello world being displayed right in there. And now you can play around with adding other things in there. You 8x8 dot draw string. Okay, so 0 characters over, 2 lines down. Okay, world, I'm and so make sure that you can display things on there. Now, the draw string function, really nice. This is using the full U8x8 this is using the U8x8 library. If you go into the U8G2 library, then you'll be able to draw graphics and circles and things like that on there as well. And so I encourage you to play around with that a little bit, but get it working at this stage first. Okay, you really do want to have that working before you go too much further. Now, I'll say the same thing for, I'm done with this, I can get rid of that. Okay, I'll say the same thing for the rangefinder. So if you want to get that working, then you're going to need a library, and there's multiple libraries out there for this too. Okay, so let's come into our managed libraries again. And the particular rangefinder that I've got is the VL 53 L0X rangefinder. Okay, that's just the name of the chip that's on it, and you can Google that, and you can find the specs for that rangefinder and other competing boards. So if you're doing this from somewhere where you'd have to pay duties to ship from Universal Solder or from Lee's Electronics, then maybe you'll find a local supplier who's going to help you out with this. Okay, so Adafruit V53LOX. Normally, I love Adafruit's libraries. And So as you can see, I installed this one. It works just fine. The problem is that when it compiles, it is a beast. It uses up about 40% of your program memory on your Arduino just running that one library. And I don't know why. Maybe I had a configuration setting in there that didn't work so well. Um, Anyway, I ended up using 103% of the Arduino's programming memory space when I put all my libraries together and actually bogged down the Arduino. So my poor old 328P chip was not powerful enough to handle all of that. Well, thankfully, there's more efficient libraries out there, and the one that I ended up going with is the VL53LOX library from Pololu. Pololu, another online electronics retailer that does a great job of things and provides support for their devices in the form of libraries. So you could probably order the sensors straight from Pololu and use the library that they've written for you. Okay, so that is just called the VL53LOX library. And so if you go and install that library, you can see I've got mine installed. Now you should have a set of examples and you should see VL53OX right in here. And let's just tell it that we want some continuous readings. Okay, now it includes the wire library, which handles some of the SPI. It handles the VL53LOX communication. It sets that up as a sensor. Okay, well, okay, you could call this Bob if you wanted. Just sensor refers to the rangefinder. And it comes down in here and we do a wire begin. If it can't detect it, it lets you know. And then it starts it up. And in your loop, it will just print your range out serial print. And what did we have that set up to? 9600 bits per second. So we should be able to watch on our serial monitor. And let's just upload that to the board and see if we can get this working. Really important that you test every device independently to make sure that your connections are good, your device is good, your libraries are installed properly, that you're able to upload and talk one thing at a time. Don't get too fancy. Okay, now you'll notice that the screen is still displaying "Hello World, I'm a Boombot." It's got its own memory on there, and we didn't tell it to stop displaying that. We just aren't telling it anymore to display that. So unless you clear the screen, it's not going to go anywhere. Right now, the Arduino should, let's open the serial port. Aha, here's a stream of data coming in right here. And if I put my finger in front of the rangefinder, if I move that screen down so it's not blocking it, you can see a bunch of data coming in right there. And I'm 170, 180 millimeters away from it. Now, you can check for accuracy. I think it's pretty good on precision, but it's a little bit off on its accuracy. It's supposed to be good out to several meters, so if I aim it up at the ceiling, that's probably beyond its range. So every now and then it's telling me, oh, it's really long, and then it's telling me that it's really short. If I put something in the way of it right here, now I'm ranging out to, gotta get my hand right in the way. It is a laser after all that's doing this range finding. And so you may have to do a little bit of filtering on your data coming back and play around with that. For most of our applications, I find that it works pretty good. But test that out with the base code. Make sure you've got it running and that you've got data coming in right there. Now, when you've got those two working, it's a good idea to go into the different files and find out what's critical to take out of each one of those to put it together and make it work. And before you start piecing absolutely everything together with all of your robot drive code, I think it's a good idea to come in here and just do a little bit of a test to try the two working with each other. And so what I've done in here is I've come in and I've included the different include files from each of the files. So actually, let me bring those examples back up. I shouldn't have closed them right away. Where were we here? U8x8. We did Hello World in there. We had that working. Okay, so out of the Hello World, I came in here and you can see Arduino.h and U8x8 lib right in there. Okay, so I copied those over. Okay, I ended up copying this over 2. I'm not sure why. I don't need that. I could probably get rid of that. Where it said, please uncomment one of these, instead of going and uncommenting one, now I've found the one that works right for me, and I just go in and I copy that line right over here. So I've got U8x8 SH1106, and just came in here. Hardware, it's the hardware I2C version that was working for me, and I just copied that line right in here. And then I have the setup right in here from this. Okay, and I didn't copy this because this was all commented out anyway. I just copied U8x8 begin and put it right in there. Okay, for my loop, I've got U8x8 dot clear display. Now, this isn't covered in the library. You actually have to go and find the online files for the U8x8 or the U8G2 library. So in your web browser, if you Google U8G2, okay, you'll find the GitHub, and you'll also find some Arduino references right in here where it talks about how to use the library, read the documentation, and so there's documentation available on GitHub. And I think I found it even in a nicer format somewhere else, but anyways, you've got documentation available for both of these libraries. So I've added a couple of new commands and experimented with that a little bit. So I've got U8x8 clear display, set cursor, and you'll notice it follows the similar format to our LCD dot print. And in fact, we can actually do U8x8 dot print line to get the carriage return in there, and print line. I'm a Boombot on there. And so there we go. I've got that part working. Now, to get the to integrate the code from the rangefinder, come down here, and we were doing continuous range finding. Okay, we did sensor start continuous. Let's just bring this right back up here. And we include wire.h, that's right in there. So these two lines, we set it up a sensor object right in here in our setup. I kind of skipped over this nice little setup where it goes out and tries to detect the sensor because we're assuming it's hooked up, but it's nice to know that you can detect that it's there. So maybe later on, if you're doing some intelligent code for your Boombot that automatically determines whether or not you've got an ultrasonic rangefinder or a I2C laser rangefinder in there, you'll be able to add something like this and make it work. I just added the wire.begin right in here, and sensor dot I use this sensor.init instead of sensor.start continuous. Maybe I was using the, where's my example files? I must have been using the single line. There we go. I use the sensor init command right in here. Yeah, this used the sensor init right in here, and it said if not set. So sensor init will be an initialization routine that returns a true or a false depending on whether it initializes. So this is saying if it's not returning a true, then anyway, figure out the Boolean. It's going to just send down here and detect to make sure that you do have the sensor operating. We've skipped over all that because we didn't really need it. I just put sensor.init in right here, and I'll hope that it initializes properly. Okay, now there's other things in the library that you can do. You can tell it that you want a long range in here, or that you can want high speed sensing. But as you can see, they're all trade-offs, and we don't need any of that. At least not right now. All we want is to be able to do a reading. And to do that reading, you go sensor, and then you just look inside the object for the read range single millimeters function. And then what we'll do is we'll print that out on the screen. So my code in here, fairly simple. It's just got the includes from each of the two sample files that we used. Okay. Actually, we can, that's all commented out. I can delete all that to try and get this onto one screen for you so it's easier to see what we're doing. That's just a comment that we don't really need in there. Okay, so there's my includes. Set up the sensor object right there, and then we come in here and in setup, okay, we start up our graphics display. We set the power save function to off. I haven't tried setting it on to see how different it looks. Um, we initialize the wire function, okay, for that's an I2C library for talking over the I2C port, and our sensor.init turns on our rangefinder. And in our loop, all we do down here is we clear the display, okay, and that's using the U8x8 library, and then we set the cursor up to the top corner, position 0, 0, very similar to your LCD print commands that we've used in different things in our course. And then we have this start time equals micro. I'm just trying to get an idea on here of how long it takes for something to print out. So I was basically looking for more data just to get a changing display. And we set the font that we want to print in. That could probably be up in the setup routine. Doesn't have to be in here every time. And we just print hello world. I'm a Boombot. And then I'll print the distance in millimeters, and then I'll get the range single in millimeters, and then I'll print out how long it took to do it, and it doesn't take long at all. And now we've got our two sensors integrated, and it's a good idea to do this as a separate step before you try to integrate it with your main Boombot code, because if these two, well, we tested them one at a time, then we test them together, and then when we know that they work with each other and don't clash, we take them into our main Boombot code. And here we go. This should flash up right on here. And now we've got fancier displays on here, and it's telling me that it takes about, there we are, somewhere around 90,000 microseconds to run all this code. So we're looking at basically 90 milliseconds to make that happen. So 1/100th of a second to actually do the printing data down there. Hopefully that's not going to interfere with anything else that we've got going on our chip, because as you'll recall from getting the LEDs to turn on right here, there are some clashes that happen in your communication, and this chip is starting to work pretty hard for what it is. Okay, so now we've got that all hooked up and running, and we want to integrate that into our main code. So I'll just keep that window open for a little bit and move it off to the side. Actually, I'll just minimize it, make it go away. And so now we've got our main code, and you can go back and you'll recall that the last episode we talked about, we'd moved the drive into its own tab. Okay, we'd moved our rangefinder into its own tab. Looks like it's complaining that something going up with the font on that. I have to change my display resolutions to get OBS Studio to record this. So normally I work at 4K. I'm not quite sure why this Arduino is giving me grief. Let's just come in here and change our preferences in here. I'll try setting that to 24. Change if I... Interesting glitch in the IDE, it would seem, that I need to come through here. And so the tabs don't work as nicely with the display preferences as we'd like. Anyway, okay, so we've got all these different tabs. Most of the stuff that we're going to do comes in here. Now that we've got the two devices working together, you can come in here, you can bring the code that you need in here to make it work. You can see we've got software serial, the DF Robot Player Mini. We did that in our last episode. Now we've got the wire functions and the SH1106 display, the VL3053 rangefinder. So I bring those functions in there and basically just copy them straight out of that integrated package that we had going on here. You will have to do a couple of things in here. I leave all this pretty much the way it was. And one of the things that you'll have to do is remember that your rangefinder is no longer functioning. You don't want it going out and having your rangefinder function pinging on the various pins that it pings on. Here's another one that Okay, so what I did in my rangefinder function right here was I just commented out this entire section right here so that that wouldn't interfere with any I2C communications that were happening. And because we no longer have the rangefinder plugged in there because we've got a little light-based one instead of a sound-based one. If you wanted, you could actually just put the code for the laser rangefinder in here and replace the ultrasonic rangefinder code, or you could come up with another function that was called, VL rangefinder or something like that, and you could call that instead. So anyway, in your main program down here, we come through here, software serial, again, this is all for the DF player. Here's our U8x8, our U8x8 set power save. For some reason, I've got that in there twice. That shouldn't be in there twice. Anyway, doesn't seem to hurt it. Here's for the rangefinder. We've got the wire begin, sensor.init. Again, you could have different names for different sensors in here. And then in our main code right down here, our void loop, each time we go around here, and I've added this command right in here. Just gonna see if I can set it to 24 so it appears nicer on the screen. Remote XY handler. So in your main loop, okay, right in here, this is where I do my update LEDs, and I keep track of this last LED update, and every 100 milliseconds I go out there and I update the LEDs. In here, I've got this set up to update our display screen with the rangefinder every 500 milliseconds. So I keep an unsigned long variable. You'll have to go back up to the beginning of the program and create an unsigned long variable. I called mine last display, but basically what this does is each time the program loop comes around, it measures what time it is, and it measures what the last time this function executed was, and if it was greater than a 500 millisecond difference, then it comes in here, it clears the display, it sets the cursor. I've got it setting the time to micros. This is basically the display that we had working in our previous example. And then we print hello world, I'm a Boombot, and it prints the range right out in here. You could print other sensor status out in here if you wanted. So instead of printing all that out, let's make this. Okay, so you can print range in millimeters, measure that. U8x8 dot. Okay, and then you could say something like, okay, keep in mind that there's a voltage divider coming into A3 that splits the voltage in half and gives us a reading. You have to come up with the actual formula. But with your voltmeter and a couple of readings and knowing that basically your seeing half of the battery voltage, and it's being ranged from 0 to 1023. It should be pretty easy to come up with the formula in there. And then this just displays how long it took it to print all that. You don't really need that on there. You can, I don't know, I'm just going to comment that out. You don't, you don't need that. This was just my testing how long it took for it to print out. And you can drop this code up to your robot. And this should all work together. We've got the remote XY handler in there. Um, yeah, we've got the same drive functions. We've got our DF Player Mini working in there, and it compiles the sketch. And it's getting to be a big sketch. It's taking up a big chunk of the Arduino memory. It's taking a while to upload. It says it's a Boombot, and now every half millisecond, it's telling me my motor voltage is 2 because the motor's turned off. I turn that on. I can see that reading in there. It's telling me the range is 131 millimeters. Like I say, I think the precision's pretty good, but the accuracy, particularly at the super close range, might be off. It looks like, right in here when I take a reading, that's closer to 60 centimeters, and it's, 60 millimeters. It's reading 120 millimeters. You'll have to play around with that and get that dialed in. Not quite sure why it's not giving me a perfect reading. Maybe if I give it a bit more voltage. No, that doesn't seem to change it, whether I'm running on battery or not. And anyways, with all that packed in there, you should be able to come along and run your remote XY. And let me connect to the Boombot network. And remote XY. And now I'm connected to the Boombot right in here. Oh, let's make this go big screen. Why not? It's getting pretty fancy now. Okay, and as I drive this forward, you can see that the voltage drops down, and the reading that I'm getting on that display screen is the same as I'm getting on the red graph on here, because I'm sending an analog read of A3 to both sides. And so I've got all my driving function working with good latency. I can make it say all sorts of annoying sounds. I've actually got noise canceling on here, so maybe I have to. So all of the functions in there seem to be working really well. And we can drop that down and do all those cool things that the Boombot's supposed to be able to do. We can play around with the colors on our displays, and as we drive, you can see all the different LEDs inside blinking away, creating a nice fancy display. All well, you've got range finding on here. You could provide that feedback as part of your feedback to your what do we call this piece of software? Remote XY. Anyway, on that note, before I forget anything else, I think that's the end of this video. Good luck and have fun integrating some I2C devices onto your board. And like I say, there's a whole range of I2C devices out there. I've got a gyro on there, and I did get that up and running in previous testing. And so now I'll probably integrate that onto there so that my robot doesn't accidentally twist off to the side. This gyro, unfortunately, seems to be a little bit slow for actually tracking its actual heading. So I'll probably get a compass sensor that can, or magnetometer, because we're not actually reading global north and south when you're indoors, but it should be able to get some sort of reading and have an absolute heading on it so that I should be able to tell the robot to turn to 90 degrees or to 45 degrees. And then should be able to use the encoders to get reasonably decent distance measurements. So I should be able to have some fairly accurate um, uh, autonomous navigation on there. Anyway, good luck. If you're getting to this point, you're probably figuring out a lot of this on your own, and you're saying that, okay, Jason, you can be quiet now. So I will.